All right, this is the beginning of activity 3.5 where we are going to investigate applied statistics. You should have watched the Edpuzzle video that talked about mean, median, mode, different types of data graphs that we would use and measures of central tendency. Right now we are on the activity 3.5 applied statistics, and I am looking at this Google Doc that says by hand. Okay, so we have part of the manufacturing quality control testing for a toy, like our Automoblocks car that we just measured, is to measure the depth of a connector piece that must fit into another part. The depth is designed to be 5.1 centimeters. Every 10th part produced on the production line is measured. The following data was collected during a 2-minute production period measured in centimeters. So I'm dealing with these numbers here as I am analyzing. They took measurements, and you can see they're not all to spec. They're not all those 5.1. And we need to know what that means. Okay, so what you're going to do, let's start off by setting up our engineering notebook. Go ahead and pause and kind of format it to look like this. What I've done, I titled my notebook and I wrote down all the data sets. This one right here is 4.8 centimeters. I know it got kind of hidden over there. The very first thing that we always want to do is to order our data from least to greatest. We do that so that we can find our median a little bit easier. Go ahead and pause the video and order everything in order from least to greatest. Okay, so I have ordered my digits from least to greatest. This is really helpful for me to figure out exactly what it is that I'm calculating for my mean, median, mode, and range. Okay, so before we do a lot of these calculations, it's really important for us to understand what our population size is. And in this case, population is pretty much how many numbers we have. We use the capital letter N to represent that. So pretty much I am just counting up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My population size is 12. I have 12 digits. To calculate the mean, median, mode, and range, these are things that you've done for a long time, but you may not have seen it written the way that it is on our formula sheet. You'll want to find your copy of the formula sheet. We are under statistics, which is the very first part here. You'll notice that I have mean, median, range, and mode over here. And then in the presentation you just watched, we talked about standard deviation. Now there are a whole bunch of crazy looking symbols, which makes you probably feel pretty smart when you write them down. But don't worry about it because every symbol is explained. So this mu, the little crazy M, is population mean. X bar or X tilde, it looks like, is sample mean. It talks about what all of those items or all of those variables are defined as. And we'll make sense of it here in a second. All right, so the very first thing we want to do is we want to calculate the mean. The mean is what we call the average. And when you learned about the mean in middle school, you learned to add up all of the numbers and divide by how many numbers you have. Well, that's the case here. It's just that it looks a little different. So the formula that we have for mean in our engineering formula sheet is this crazy looking thing right here. And we're going to go ahead and use the population mean. So I'm going to use that mu. It looks like an M, but it's not. The sigma notation, which is a crazy Greek looking E, and the E just means sum of everything divided by N. What this means is I am taking, so that sigma x sub I is sum of all my data values. Add them all up. What you learned in middle school, it just looks a little different. N is the size of the population. Divide it by how many numbers you have. So this crazy looking notation means the mean is found by adding up all your numbers and dividing by how many numbers you have. All of that is represented in symbols to kind of make it a little bit more efficient once you understand what those symbols mean. Okay, so you are going to need your calculator. And once we open up our calculator, make sure it is turned on. We are going to add up our numbers, starting with 5.1. So 5.1 plus 5.1. Let's see. I'm going to pause while I do my adding. Okay, when I added up all my numbers, I got a sum of 60.8. I actually made a mistake. That's what that second line is. So it's really important when you're typing all these numbers to watch your calculator carefully and make sure that you get them all entered accurately, which I bank failed and made a mistake. All this means, what I did is I found my sigma x sub I. I found the sum of all of my data, all of my numbers in red, to be 60.8 centimeters. Then I'm going to divide it by however many numbers I had, which in this case, our population size is 12. So 60.8 divided by 12. I'm going to go ahead and take my calculator, take that answer, divide it by 12, and I get a mean or an average of 5.06 repeating. So 5.066666, and there's that 7 that tacks on at the very end. I know there are a whole bunch more sixes, but that 7 is just a rounding error at the end of your calculator. Just believe me, there are 6s going forever. Now, according to our significant digits, we want to take any answers that we get and go one more decimal place past what our answer or our data set is provided. So in this case, all of our numbers are to the 10th, so we want our answers to be rounded to the 100th. I'm going to look at that 6, that's my 100th. I'm going to look at the decimal, or the digit in the thousands place, in this case it's a 6, has enough power to round that up. The answer I'm going to provide is 5.07 centimeters. That is my mean. Okay, median. Median is my middle number. This is why it's so important to arrange our numbers in order from least to greatest. The middle number, we're just going to go ahead and cross them off from one end to the other as we go. And I find that I actually have two numbers fighting for that middle. When I have two numbers fighting for the middle, it's called where we're going to have to find the median. We're going to have to add those together and divide by 2. So we're finding the middle of these two medians. So what I do is I take 5.0 plus 5.1, and I'm going to divide them by 2. Add up those middle numbers, 5.0 plus 5.1, hit enter, and then I'm going to divide it by 2 to get 5.05. Now, some of you may have been able to do that in your head, and that's awesome. My median is 5.05 centimeters. That means out of all of those measurements, 5 and change would be in the middle of all of those results that we collected. You want to make sure that you include that centimeter unit to help us out. Okay, the second to last one that we want to do is called mode. So I am looking for which of these numbers occur most often. And in this case, I have a few. I see that 5.0 occurs 3 different times, and so does 5.1. This is called bimodal. I have 2 modes, and that's completely okay. I'm going to list both of them. So 5.0 and 5.1 are both considered my modes. They're 2 of the numbers that occur most often. Range is a measure of variability. Range, if I keep looking at my formula sheet, which I forgot to do, so median we did, place data set in ascending order, that means least to greatest. We did, we have an n that is even, so our median is the mean of the 2 central values. That means we take the average of the middle number, which we did. Mode, we put our data in order and found the most frequently occurring. If 2 values occur with maximum frequency, it's called bimodal. If we have 3 or more, that's called multimodal. Our range here is a measure of variability. A range is where we take the maximum value minus our minimum, biggest minus smallest. In this case, it would be 5.4, or X max, minus X min is how we find our range. So 5 4/10 minus our smallest value of 4 8/10 centimeters gives us a range, 5.4 minus 4.8 of 6/10 of a centimeter. That's quite a bit of variability between what it should be. That means all of our measurements are within a 6/10 of a centimeter range. That's kind of a significant difference when you're talking about toy manufacturing. Now, what we're going to do is in the next video, we're going to talk about the standard deviation, which I will have you pause and write down all those steps in the next video. But we're going to measure and determine exactly how variable and how off all of these measurements are. And what that does is it tells us, were we really good at manufacturing this toy to spec? Or did we have a lot of variability or variation in our production and our measurement? What happened? In toy manufacturing, it's not that big of a deal to have a lot of variability. I mean, it can be, especially when you're talking about a connector piece. Because if you're trying to connect one part to the other, if you have all these pieces that are way off, like there's a big difference between 4.8 centimeters and 5.4 centimeters. That may mean that that part won't actually function. But in airplanes, when we're talking about bolts, that tolerance level is crazy small. So this kind of range, or standard deviation, which we'll calculate next, could be the matter of life or death. So that's where statistics comes into play in manufacturing and engineering.